Section 1.3, Linear Equations in One Variable. First of all, let's recall that an equation is a statement that two expressions are equal. So an equation, surprisingly enough, will have an equal sign. When we solve equations, there are three possible outcomes. We can either have an identity, which is when our statement is true for any value of the variable. Some examples we have are 6 equals 6 is a true statement, or x equals x, or negative 15 equals negative 15. These are all true statements. 0 equals 0. In which case, whatever x equals, the statement will still be true. Another possibility is to have a contradiction, which is when the statement is never true. For example, something along the lines of 28 equals negative 5. This is a contradiction since 28 never equals negative 5. And then lastly, we have conditional. And conditional is when the statement is true for some, not all, value or values of the variable. For example, saying that 2x equals 14. This will be true for when x equals 7, but that's the only time that it's true. We're going to specifically look at linear equations in one variable, and that variable is usually x, but keep in mind that the variable can really be any variable. It can be y, it can be a, it can be alpha, it can be theta, but usually we default to using x. A linear equation in one variable can be written in the form ax plus b equals 0. There we go. Where a and b are going to be elements of the reals. So a and b are real numbers, and a does not equal 0. So we do need to have that x term. This is also known as a first degree polynomial, since x is raised to the first power. Let's look at an example. We're going to go ahead and solve the following linear equations. You've got 4 examples on your screen. This is somewhat a review of algebra, so try this on your own first, and then resume the video when you're ready to check your solution. Okay, for the first one, we need to distribute our 3 first. We end up with 3x minus 7 equals 3x minus 6. We can subtract 3x from both sides, which leaves us with negative 7 equals negative 6. This is a contradiction. This means there is no solution, which we can express as either the 0 with a dash through it or the 2 squiggly brackets with nothing inside. Both represent the empty set. I do not care which of these 3 methods you use. You just need to use one of them. Alright, let's try example B. We want to simplify first. We get 3x minus 6 plus 7x equals 1 minus 2x minus 1. We can combine like terms to get 10x minus 6 equals negative 2x. This gives us that 12x equals 6, so x equals 1/2. Or you can write it the set that includes the element 1/2. Both solutions work.